So the term naturalistic viewing conditions can cover a wide array of stimuli, right? We have some of the older videos that we've seen, simple point light displays to evoke biological motion processing, facial change of expression. This would be the retinal input into a rodent. This would be for a human, the global motion patterns that we're used to seeing. But that's not what we find super engaging. What we like to watch are things more like this. Multiple camera angles, you're inside the car, you're outside the car, you're looking from first-person perspective, there's sound effects, there's music, you're doing social processing, you're doing verbal processing, and you're doing all this naturally and very, very smoothly. About 4 years ago, we came up with the idea of wanting to make a movie that would essentially create an acquisition state for FC studies that would work for people who can't tolerate task-free rest. And primarily, I'm a child psychiatrist. We were primarily thinking about children and individuals with psychiatric disorders. What we wanted this movie to do were sort of these two competing antithetical goals. We wanted to provide enough engagement to help people stay still, but we also didn't want to drive all the cognitive processes that you just saw being driven in those clips. So what we came up with was a 7-minute animation. We hired professional artists to make this movie, and it had some very unique features, one of which is there's no scene cuts. We used a fixed camera angle to impart this feeling of stillness. It's non-social. At least we tried to make it be non-social. It's non-verbal, and it uses abstract imagery. The score that accompanies the film was also original, and it was meant to be calming and just very consistent throughout the whole 7 minutes. And the composer also took the noise that the EPI sequence makes during scanning, and she tried to incorporate that or musicalize it into the score. So I'm going to let you just see a couple seconds of this movie called Inscapes. It starts with a fixation cross, of course. Hear the scanner sound in the background. So this movie is now publicly available for download. It's being used by a bunch of groups in a bunch of different countries with some fairly sizable data collections happening. I'm going to focus on just a small data set that we have that we used initially to look at how the FC was being modulated across these distinct movie watching conditions and rest. So we have 3 7-minute conditions. Our comparison condition was a clip from Ocean's 11. We have 2 scanning sessions with a scan interval of 7 days, and I'm going to be showing you data of 34 healthy subjects. So right here, we're just looking at FC matrices using the CRAD 200 parcellation, and this slide is just to show that you can see these patterns are conserved across these conditions. However, when you make, the movie content actually does matter. So inscapes and rest are more correlated than they are each with oceans. What we also found when we looked at the whole brain level was that both within subject and between subject FC correlations were stronger for movies relative to rest. So that's great from a retest reliability standpoint, but we started to get a little bit concerned about individual differences. So the question was, are we driving your brains to all look the same and thereby covering up the individual differences? So to answer that question, we adopted the same approach that Finn and Shen had used in their 2015 paper, the so-called fingerprinting approach, which is basically just this test-retest matching algorithm. It's a really simple, elegant way to do this. You just take a single FC matrix from a single subject, and you calculate all the correlations with every other matrix in the other data set. And whichever correlation is the strongest, you declare that the winner. And if the algorithm has managed to pick out a matching pair of subjects from within all of these matrices, then we call that correct. They picked out a correct pair. So the output of this algorithm is accuracy. So in the next few slides, that's what I'm going to show you, is just accuracies of these algorithms. When we tested this across our different movie conditions, rest, inscapes, and oceans, we got a range of accuracies from 61 to 100%. And you can see that that 100% comes when you're matching an Ocean's 11 scan to an Ocean's 11 scan. What was interesting is that you can also match really, really well across movies, so inscapes to oceans, and you can also match really, really well from oceans to even rest. So this is very interesting, right? The individually distinct FC patterns that I have are persistent across these very different acquisition states. There was a very recent paper that just came out where they did that exact same matching algorithm, but they did it in kids. And they had a huge data set, and they used data from REST, from a working memory task and an emotional recognition task. Their range of accuracies was lower, huge data set though, and this is kid data, and they were ranging from 37 to 60%. The really cool finding of this paper though is that the distinctiveness of the connectome is very strongly related to age. So it seems to be that this distinctiveness is a result of a maturational process. So of course we got very interested in this and thought, what about using movies to do the same thing in kids? So to do that, we turned towards the Healthy Brain Network biobank data, which you're going to hear about at the end of the symposium. We took basically 76 of the low motion subjects, and we had a mean age in those kids of 12.2 years of age. When we ran the algorithm, we had 2 separate rest blocks of each of 5 minutes, and we had a 10-minute movie that we split in half. So that's movie A and movie B. And the percentages that we got, the accuracy of the matching algorithm, had a pretty big range. So we're looking at from 26 to 96%. So that 96% jumps out, because that is way, way higher than what was attained in the Kaufman study that I showed you just right before. Rest is okay, coming in at 58%. And what was really interesting is that when you try to go across condition in kids, it doesn't work as well. So this brings up all sorts of questions, and there's lots we need to do. We just got these results, so there's a lot we need to do to make sure they hold up and check different pre-processing strategies. But the question is there something going on developmentally whereby an individually distinct pattern exists in kids when you drive the brain with complex processing? But when you look at this data under resting state conditions, the kids look much more alike across subjects, and those distinct patterns don't show up. So we have a lot of questions to ask about this. So we're going to stop there. I would say the main conclusions of our data so far suggest that movies preserve, they don't cover it up, and perhaps enhance our ability to detect these individual differences in FC. And then the question about, is there something interesting going on developmentally with kids and individual differences in FC that movies can help us investigate? So I'll stop by saying thank you to the many collaborators. One of the other things that you're going to hear throughout the symposium is that movies are fantastic for collaborating. So